So very good morning students. So today we are with our fourth experiment, that is the clipping circuit. Okay, we are going to construct clipping circuit. Okay, so what are the clipping circuit? Okay, so basically the clipping circuit is that type of circuit. It is that type of electronic device that is used to evade the output of a circuit, okay, to go beyond the preset value of voltage level without varying the remaining part of the input waveform. Okay, so these type of circuit are called clipper circuit. Okay, this means that we can remove a portion of the waveform, the positive or the negative half. Okay, so the clipper circuit is a circuit in which a waveform is shaped is removed by or clipped by a waveform. Okay, for example, the positive clipper is that circuit which removes the positive half of the input voltage, and the negative clipper is that type of circuit in which we are removing the negative half cycle of the applied input. Okay, so just see here, I have drawn the circuit and I have drawn the waveform also. So you could see here, this one is a positive clipper circuit. Okay, when you are going to supply the AC voltage here, the AC source, okay, or the AC supply, when you are giving for positive clipping, what we need to do, we need to add a diode, okay, in reverse bias condition. Okay, so that in reverse bias condition the positive half of this waveform doesn't exist at the output. Okay, but it shows the negative waveform. Okay, what's the reason? Whenever the positive cycle is going through this diode, what happens? This diode comes to be at a reverse bias condition and it doesn't allow any signal to pass through it. And when the frequency changes, and at the portion when the AC supply is giving here negative voltage, what happens? This diode comes to be at positive biased condition, and at that time this circuit gives the output. I mean to say, since in the AC supply, what happens now? This positive and negative things changes every time. So when at this portion, suppose at this portion this would be A. Okay, when there is a positive voltage here, then at that time what happens? This diode comes to be in reverse bias condition, and at that time what happens? There is no output. Okay, just see here, when the positive for the positive half cycle, this diode comes to be in reverse bias condition and it doesn't give any output. But when this portion is getting a negative voltage, what happens? This diode comes to be in reverse bias condition, and at that time what happens? This diode acts as a forward bias condition, and at that time it gives the output voltage, okay, which is supplied at the input portion. So for the negative half cycle, I am getting a negative portion of the output supply. Understood? So similarly, for this negative clipper, what I am going to do? I am going to use this diode, the silicon diode, as a forward bias condition, okay, for the AC supply. So when this portion is getting a positive half cycle, what happens? This diode is passing the current or voltage through it. Okay, at that time I can see output here for the my positive input half cycle, but for the negative input half cycle, this diode comes to be at reverse bias condition and it doesn't give any output. So just see here, for the negative portion I am not getting any output. Then again for the positive portion of input I am getting a positive output, and for negative thing I am not getting any output. Okay, so this thing we will do here, the positive clipper and the negative clipper circuit. So here you see, this is for the observation, the input waveform, positive clipper and negative clipper. Okay, this one is off time and on time for input waveform, positive clipper and negative clipper. This one is amplitude or voltage. Okay, so off time and on time, what is this now? You know, and that in one time period of any signal there is one off time and one on time. Okay, just see here, the on time of this input waveform should be equal to the on time of this output waveform. Okay, we will match that this thing is happening or not, and we will also find the amplitude of the signals. Okay, so these are the procedure, the results. Okay, precaution you have to write on your own. So I am going to perform this experiment in the multisim. Okay, so I am going to switch on my multisim here. So this is multisim window. Okay, so here I am going to perform the experiment. So firstly I am going to choose the diode, the silicon diode. The number is 14007. Okay, 14007. Okay, so now I am going to choose a resistance here. Take it to be 1 kilo ohm, simple resistance. Okay, now from the source I am going to choose a AC voltage source. This one is my AC voltage source, and also I am going to choose a ground here. Okay, fine. So we have chosen the components here, and I am going to currently join this thing. Okay, suppose firstly I am going to join the positive clipper. Okay, so I am going to perform the positive clipper one. Okay, so just I am going to flip this one horizontally. Okay, and I am going to rotate this one. Fine. So just look here, I have connected my whole of the circuit. Now for checking the output I do need oscilloscope. So just see here, there is wattmeter, function generator, oscilloscope. So I do need 2-channel oscilloscope because I need to check 2 different outputs. Okay, so this one is my channel A, this one is my channel B. So the negative portion would be connected to the ground. Okay, so just look here, I have connected it to the ground, and the positive portion I am going to connect it across the resistance R1. So my A channel is connected across R1, and my B channel I am going to connect it across the voltage source. Okay, so my A channel oscilloscope, the positive portion is connected here at R1, and the negative one is connected to the ground. And also in the B, the ground here, this line is, since it is connected to the ground, so I have connected the negative of B to the ground here only. Okay, and the positive one of the B I have connected here. Okay, to the positive source. Now what I am going to do, I am going to run this simulation. Afterwards I am going to double click on the oscilloscope. So just see here, I am getting the output waveform. Okay, so it's not coming a good one. Okay, so I am just going to change it. Okay, but look at the voltages here. Okay, the voltage is fluctuating because this one, the voltage is changing continuously since it is a sine wave source. But look at the time of T1 and T2, both are same, that is 1.530 and 1.530. Okay, so T2 minus T1 is 0.000 second. Okay, so leave this thing. Firstly I am going to decrease the voltage division here, so that I could get a good waveform. Fine. So also I am going to decrease the waveform of this one. Okay, so it is one is of 500 millivolt, so I would make this one also 500 millivolt. And now I am going to decrease the time division. So just look here, I have done it, and now I am going to click on this single one. Okay, for a single waveform thing. Okay, so just look here, this whole waveform. Okay, this whole waveform is my input signal, and just look here, this negative clipper. Okay, for the positive input cycle I am not getting any of the positive output, but for the negative portion, yes, I am getting a negative voltage here. Okay, so this is my negative clipper cycle. Okay, sorry, negative clipper circuit. Okay, now I am again click on this auto button. Okay, so now what you have to do, you have to check that what is my voltage and what is my time division. Okay, so the best portion is to pause this thing. Okay, now I have paused this thing. I would use this cursor. Okay, so just see here, I'm clicking on this cursor at this time, and I would place this cursor on the second one. Okay, just see here, and here I am seeing that this T1 minus T2. Okay, so it is showing me T2 minus T1 is minus 994.318 microsecond. So that means that T1 minus T2 is 994 microsecond. Okay, and here I have seen that I have given a 1 kilohertz input cycle. Okay, so that means our frequency is not changing, but yes, the voltage is changing. Okay, now since voltage is changing, so you could see directly from here that the whole of waveform is containing 1, 2, 3, 4 vertical boxes. Okay, and here the channel scale is of 500 millidivision. Okay, so we could say here that yes, it is of 1 volt and it is of 1 volt. Okay, similarly the negative is containing only one of this box. That means that yes, it is getting only half of the highest amplitude. Okay, that means that it is getting only 500 millivolt. Okay, if this one is getting 1 volt of amplitude, this means that for the negative half cycle we are getting only half of the volt. Okay, sorry, this whole of the waveform, the input waveform is getting 1 volt maximum voltage, and the 1 volt negative of the voltage. At that time I am saying that I am getting half of the negative voltage. So we could see here that my output is low here. Okay, so it is decreased by 50%. Okay, understood. So here you could also see here this channel A and channel B is present here. So channel B is showing this channel B is showing the output from this input source. Okay, so the channel B is showing minus 994 millivolt. Understood. But the channel A is showing 474. So it is around a half of this thing. Okay, a little bit less than, I think a little bit it is nearly about the half of this channel B. Okay, so we are seeing that output is decreasing. So in this observation I could write here off time and on time. The off time and on time of both the input and output waveform is 994 divided by 2. Okay, because 994 is from here to here. Okay, understood. So I could just take this from here to here, and I would show you that yes, what is the off and on time. So just see here. Okay, it's looking good. Okay, so we would just make the division look more good, so that we could get a more of good data from here. Okay, fine. So just look here, we are getting 500 microsecond. Okay, so this means that this is the half portion of the positive cycle. Okay, sorry, I have taken it for the positive cycle. Sorry, so I would take it for the negative cycle here. So just look here. Okay, fine. So at this time, okay, approximately we are getting to that point. Okay, okay, fine. So I have got at this point, just see here, the negative cycle also 500 microsecond. So the off time of the negative this first one, that is the positive clipper, no? Yeah, the positive clipper. Yeah, so the positive clipper off time is same as that of the input waveform. Okay, and there is no on time for this positive clipper. The on time is only for this input waveform, and the off time and on time are both are same. Okay, but the amplitude of both are different. Okay, so you have to write the amplitude here, and the negative, in the negative clipper also we will get the same off and on time, but I will show you that how it looks like. Okay, So I'm going to close this one. I'm going to close the simulation here also. And now what I'm going to do, I'm going to just disconnect the connection from here, and I'm going to flip this thing, okay, horizontally, this diode. Okay, now I'm going to connect it here and this portion to here. Okay, so now this portion would work as negative clipper. So my second portion is of negative clipper. Okay, so this would remove the negative half cycles. So again I am going to run this thing. Okay, and after clicking or running this thing, I am going to turn on the oscilloscope here. Okay, fine. So just see here, I am again going to use the single button, or just I am going to pause this thing. Okay, so pausing is not making it looking good, so I am going to click on the single portion. So just look here, for the negative half cycle of the input waveform, I am not getting any negative output, but here also you could see here that there are 4 boxes, okay, in the input waveform, and one box in channel B is of 500 millivolt. So I could say here that I have got 1 volt peak to peak, sorry, 1 volt of amplitude here for the positive one, but for the negative one I am getting nearly about 1 box. Okay, so 1 box is of here 500 millivolt only. Okay, so if I am going to make it auto, okay, just see here. Okay, now again it is changed since the wave is running, so it is showing me this waveform thing. Okay, so I am going to click on this pause button right now. So just look here. Okay, so what I am going to do, firstly I am going to give you the output of this waveform time on. Okay, so just look here. Okay, it is currently 503.778 microsecond. Okay, so this one is what it is, our time on period for this input waveform and the output waveform. It is approximately same as that of the positive clipper one. Okay, similarly in that case, in the first case, I have got the voltage as 1 volt here. Okay, so in this thing also I am getting that around 500 millivolt is input maximum voltage of this oscilloscope. Okay, so this is how the positive and the negative clipper looks like. So what you have to do in this experiment, I am going to just stop this simulation. So what you have to do, you have to you have to take the output of both of the oscilloscope at the input, at the positive clipper point and at the negative clipper point. Okay, that means that simply you have to get the output of the oscilloscope. Now this thing you have to do by your own, that how do you take the output of this oscilloscope. Okay, you could directly click on the picture, or you could take the output in the PDF form also. Okay, so just look at the Google and you will find out that how to take the picture of, not the picture, sorry, the output of this oscilloscope directly into a PDF format. Okay, just check that thing, that whether it is possible or not. Otherwise you could do it in another way. Okay, but this thing you have to do it by your own, that you have to take the output of the oscilloscopes in both the cases, in the positive clipper case and in the negative clipper case. Okay, and there you will show T1 minus T2, and here in the observation table also write that T1 minus T2. What is T1 minus T2? That is in this positive clipper thing, just choose the time period for T1 minus T2 to here, from this thing to this thing. Okay, and in negative clipper, just choose the time T1 minus T2 from this one to this one. Okay, T1 and T2 are not time period, but they are the time cursors. Okay, in the oscilloscope we do use cursors for finding the differences between x-axis or y-axis. Since x-axis is in oscilloscope, it is showing what this x-axis is showing the time period, okay, in the oscilloscope, and this y-axis is showing our voltage. Okay, so T1 minus T2 could directly take the value from the cursors at point T1 and T2, and they could show you that yes, what is T1 minus T2. So if there is any issue, you could contact me via WhatsApp or you call me. Okay, and you have to fill up these data in the observation, and you have to take the output of the oscilloscope also. Okay, and you could put it at the end. Okay, here, and the result you could write here. The circuits were constructed and the graphs were drawn on oscilloscope. Precautions you have to write on your own. If you are getting any conclusion, you would write there also. Okay, so this was our experiment 4 end. Okay, so thank you for all.